Hello everyone, in this video we're going to tackle some extra examples in how to check limits that might go to infinity or to minus infinity in any of the cases. Also relate them with the concept of an asymptote and checking for the specific points that might also have an asymptote or not. So first, let's work with this problem. We're going to determine analytically what's happening when we're approaching 0 with the function phi over x. So for that, the best thing that we can do is make a table. And so as always, you can just create a table, x and f of x, phi over x. And so you can start giving some values here. Close to the point that you want. So for example, we're approaching 0 by the left. So we can start with minus 0.1 and then go to minus 0.01 and check the values of whatever that's going to produce in here. And so take a look if this is going to a certain point, specifically checking if this is going to approximate infinity or minus infinity. But let's do that directly on the grapher. So in here I have the function f of x equals phi over x. So I can go ahead and start calculating numbers that are close to 0. So if I move from the left side, you can see that every time that I move closer to 0 from negative numbers of the left side, you can see that the value is getting larger and larger. So we can see that this is going to minus infinity. And so it makes sense with the graph here. You can see that every time that we get closer and closer to 0, the graph is going further and further down, checking out to minus infinity. On the other hand, if I just choose to do the same thing but by the right side, clearly you can see that that's going to go to infinity. But let's confirm that by doing the same values. So I can approach with numbers closer again to 0. And so every time that I get more and more close, then you can see that the number is really big. And so clearly this is going to infinity. So from that, we can conclude here that analytically, you can fill the values of the table, and you can conclude that from this side, from the right side, this is going to go to infinity, and from the left side, this is going to go to minus infinity. Okay? And so that's exactly the same approach that we're going to use for the next function, which is going to be x squared minus 4x plus 3 divided over x minus 2 squared. So let's take a look. Now, notice that clearly we can see from the graph that we indeed are going to have an asymptote at 2. And the graph is telling us, yes, this is going to go to minus infinity. But let's actually prove that using the table. So if we're approaching 2, remember we need to take points by the right side and by the left side so we can prove with our table that that this is going to minus infinity. So let's start with the right side, so number bigger than 2. So I'm going to start with 2.1. Okay, so 2.1 is already going to produce minus 99, so a very large number. Now if I go with something like 2.01, notice that the jump is even quicker. It already produces minus 9,000. And if I go further with a couple zeros more, sorry, 2 here, then we can see that the number is going to be extremely large and approaching to minus infinity. So that's good enough. These 3 points are going to be more than enough to fill our table. And so the rest that we can do is do the same thing, but now with an approach by the left side. So approaching by the left, we can start with 1.9, and notice you have a certain symmetry here with minus 99. Then if I do 1.99, it's going to be actually similar value that 2.01, and from there I can use another one more. I can use g of 1.999, and so at this point I can see that we're approaching a very large value that goes towards minus infinity. So from this, again, we can go back in here and claim that in both cases this is going to go to minus infinity. And also clearly this is going to have a vertical asymptote at x equals 2. Since this point is going to minus infinity into minus infinity, is producing a vertical asymptote, okay, in x equals 2. We don't have any other issue on the domain that that might produce an asymptote, so this is going to be our only asymptote in this case. Now another function that we can take a look and see what happens is going to be the function x minus 2 divided x to the 5 minus 4x to the 3. Okay, so initially we might even think, well, let's see what happens, because clearly it looks like this is going to have more than one asymptote. Notice that 0, it is indeed a problem, because you can factor out x to the 3, and if you factor out x to the 3, you get x squared minus 4, and then later you can factor out this even a little bit more. Notice that the x to the 3 is going to be an issue with this, so this is definitely a candidate to asymptote. On the other hand, notice that I can factor this a little bit more as this, and so this is going to cancel out the x minus 2, and I can transform this in a very different function. But now this shows and reveals that the real issue is not only going to be in 0 but also in minus 2, which was our other candidate here to be an asymptote given these limits. Okay, it doesn't seem like if I take the limit when x goes to minus 2, this is gonna have a fix that I can cancel something, so it doesn't produce infinity value or minus infinity value. So very likely we're gonna end up with an asymptote at 0 and an asymptote at minus 2. But we can take a look at the values on the calculator for this. So let's go to the next. And so first, notice the graph. Initially, the graph reflects what's going on in 0. In 0, if we take the right side, this is going to go to infinity. And if we take the left side, it's going to go to minus infinity. Again, the approach to prove this is to create a table and to give some values to prove that. We can use a calculator here to approach those values. So for example, we can go with 0.1, right? And then start moving closer and closer to 0. 0.01. And 0.00001. Okay, and so notice that this every time is a larger and larger value, so we can see that it's clearly going to infinity. Now if we do the same thing, but we move this with minus, right? With minus, this is going to produce the opposite effect. Now, it's going to be a large value, but then it's going to go to minus infinity. So we can see clearly that right side goes to infinity, left side goes to minus infinity. So we can now put the values in here. So this is right side goes to infinity, left side goes to minus infinity. And we can justify this creating a table like this and use the values that I just got on the calculator. Okay. Now let's do the same thing, but let's do now the -2 value. So with the -2 value, we can approach it by the left first, and so we can use these values and modify it a little bit. So -2, -201, and -2001. So notice that in here we're really getting really close to -2. We can use even another one and say h of -2.000001. And so now we see here that we have a very large value. This is going to infinity, and so this is coming from the left side to 2. Now if we're gonna go by the right side, notice that this is values that are smaller than -2, so -1.9 and the sort. So for example, if I try -1.9, this is the function h, then this is going to give me already a negative value, which makes sense because we're going to go to minus infinity. So -1.999, which is really close to 2, is already a very large value. And finally, if we take -1.9999, closer, much more closer value, you can see that this number is going to be very large. 10 to the 9 is more than a billion. And so you can see that this is going to approach to minus infinity. Okay, so left side infinity, right side minus infinity, and we can complete these values. Okay, and so that's exactly how to determine analytically doing this table, how the limits are going to be, and just check them out. Of course, we're doing a little bit of cheating because we're using the graphing calculator to help us out, but doing the tables and getting the values is going to give us enough information to be able to tell that this goes to infinity or minus infinity.